Section 6.1, Percentage Composition. We'll start with the law of definite proportions. A compound is composed of two or more elements. In the late 1700s, a chemist by the name of Joseph Louis Proust discovered the law of definite proportions, which states as follows. Elements combine in fixed ratios to form compounds. So that is to say, compounds have fixed percentage compositions by elements. So, for example, water is formed by the combination of two hydrogens and one oxygen. Doesn't matter how that water was formed. Water will always have a fixed ratio of two hydrogens to one oxygen. And as a result, the composition or the percentage composition of water is always fixed. When we perform percentage composition calculations, we are determining what percent of each of the compound each element is by using mass. We can do this with mass data, and we can also do this using masses from the periodic table. So the first way we're going to tackle this is using mass data. So the general formula used is percentage of an element is the mass of the element over the mass of the compound times 100%. So a 22.5 gram sample of water was produced by reacting 2.5 grams of hydrogen gas and 20 grams of oxygen gas. Determine the percentage composition by mass of the compound and report the percentages to two decimal places. So if I want to find the percentage composition of the, let's start with hydrogen, right? So the percent of hydrogen is equal to the mass of hydrogen over the mass of water times 100%. The mass of hydrogen given in the question is 2.50 grams. The mass of water given in the question is 22.5 grams. I'm going to multiply that by 100%. And I end up with 11.11% hydrogen. If I wanted to find oxygen, I would do the same thing. Mass of oxygen over the mass of water times 100%. And we'll do this calculation quickly first, and then I'll show you another way of arriving at the mass, or rather the percentage composition of oxygen in water. So here we go, times 100%. And there we have 88.89% oxygen. Now, since there's only two elements in this question, hydrogen and oxygen, so since there are only two elements, once you have the percentage of one, you automatically have the percentage of the other because both percentages add to equal 100%. So if you wanted to find the percentage of oxygen, you actually didn't need to do this calculation here. All you had to do was get 100% minus 11.11%, the percentage of hydrogen, and you would get the same answer, 88.89%. However, if you have more than two elements, then you do have to calculate the percentage of multiple elements using this method here to find out what percentage all the elements make of the compound. This one is very similar to the previous question in that we have two elements. We have carbon and we have oxygen. It is different because we are given the mass of carbon dioxide, right? And just the mass of carbon. Okay. So we'll first start with the percentage of carbon. And so the mass of carbon over the mass of carbon dioxide. And that's equal to 8.40 grams over 30.08 grams times 100%. And we end up there with 27.92% of carbon. Now again, since there's only two elements here, right, I can just then say the percentage of oxygen is equal to 100% minus 27.92%. And so the percentage of oxygen is equal to 72.08. The question, however, also asks me for the mass of oxygen that reacted. So using the law of conservation of mass, which is that in a chemical reaction, matter cannot be destroyed, it can only be rearranged, and we saw that at the beginning of the reactions unit. If you know that 30.08 grams of carbon dioxide formed and 8.40 grams of that came from carbon, the remaining mass is your mass of oxygen, which is 21.68 grams of oxygen. So let's check to see that we've completed everything the question has asked for. 30.08 grams of carbon dioxide was produced when 8.40 grams of carbon reacts with oxygen. Find the percent composition by mass of carbon dioxide. Okay, I did that. I have my percent of carbon, my percent of oxygen, and then determine the mass of O2 that reacted. I found that out by using the law of conservation of mass and subtracting one of the masses of the elements from the mass of the product. And I was able to get the mass of, or the missing mass, right? So just to review this, if you take 8.40 grams of carbon and you add it to 21.68 grams of oxygen, you will in fact get 30.08 grams of carbon dioxide. Complete the following problems below. So 1, 2, 3, 4. Okay. Answers are provided there.